All right, so this is the first video on statistics part of this lecture, this section. So this first video is going to be on random variables and then mapping random variables, getting the mean and the expected value of random variables. So suppose we have a dice, a fair dice, and we roll the dice, right? All possible outcomes can be illustrated right here. So random roll of a dice, it's going to be a 1, a 2, 3, 4, 5, or a 6. That's the whole set of possible outcomes. And each outcome has a probability. So the probability of V1, which is, let's say V1 is 1, probability of a 2, probability of a 3, probability of a 4, probability of 5, probability of 6. So we want to map these events to the probability of that event. So the mean is the same thing as the average, which is the same thing as the estimate. They're all equal. So we want to take V1 times the probability of V1 plus V2 times the probability of V2 plus V3 times the probability of V3 plus and so on, all the way until we've enumerated the entire set. So a random variable with m possible outcomes. We can illustrate that here with the sigma notation, right? The mean is equal to sigma, which is the summation, right? You're adding all of them up, v sub I multiplied by the probability of v sub I. So this is a shorthand way of writing all of this. And m is the number of times we'll add each of these this event times the probability of this event. So let's demonstrate this with an example. So probability of V1, this is going to be for a loaded dice, a loaded die, right? An unfair die, right? Which means that each event, each possibility is not equal. So we'll say probability of a 6, we'll say V6, is 0.3. It should be 1/6, right? If it was a fair dice, they would all be 1/6, 1 over 6. But this is a cheating dice. It's a loaded die. So probability of V1, V2, and V3 is going to be 0.1. Probability of V4 and V5 is going to be 0.2. And probability of V6 is going to be 0.3. Right? And then here are the events. 1, 2, 3, 4, 5, 6. All right, and here's the probability. So we want to add all of these up. Right? So 1 times 0.1 plus 2 times 0.1 plus 3 times 0.1 plus 4 times 0.2, because you see here probability of V4 is 0.2, plus 5 times 0.2 plus 6 times 0.3. You look at probability of V sub 6 is 0.3. You add all that up, you get this 0.1 plus 0.2 plus 0.3 plus 0.8 plus 1 plus 1.8, and you get 4.2. So the mean of the loaded die is 4.2, whereas the mean from a fair die is 3.5. And if you think about a fair dice, each probability has a 1 over 6 chance. All right, so this is going to be an illustration of how to calculate the probability, the expected value of a fair dice. So let's say V1, event 1 is 1, event 2 is 2, event 3 is 3, event 4 is 4, and so on and so on. Right? And the probability of V1 is 1 over 6, probability of V2, 1 over 6. They're all going to be 1 over 6 because it's a fair die. They're all equal. So if we wanted to calculate that, we would do 1. We're going to do multiplication here. What was it? 1 over 6 plus, and I'm just going to copy and paste this. All right, so it'd be event 2 times 1 over 6 3, 4, 5, 6. And what do we get? It should be 3.5. Oops, I forgot. There we go. 3.5. This is the expected outcome of a fair die.